Here's problem 11 from the midterm review for Pham. It's setting up but not evaluating some intervals for the volume of so the solid obtained by revolving the region bounded by y equals x squared, x equals 3, y equals 0 around the x-axis. So to draw the region, so y equals x squared looks like your usual parabola. X equals 3 is a vertical line, and y equals 0 is the horizontal line, the x-axis. So I'm going to get this region here, because that's the region that has all those as boundaries. And not that you need to draw the next picture, but you could draw the next picture, be like, oh yeah, it's going to revolve, right? It's going to look like, so I'm just going to really draw this. It's going to look like that, and it's going to kind of, right, it's going to look like that, kind of. Like that. And so we've got like, something like that. And so to find the volume of this, or to set up an integral to find the volume of it, we always draw a strip that is perpendicular to the axis of rotation. And then when that strip gets revolved around, it's going to look like a disc, right? It's going to look like that. And the volume of that disc is pi times the radius squared times the thickness, which is dx for going around the x-axis, or dy for going around the y-axis. The radius is just the height of the strip, which depends on the function, right? If you move for the left, it's lower. If you move for the right, it's higher. So the radius here is just the function x squared. So volume of my disk is pi times x squared dx. And then the total volume is just, we're adding up all the disks from x equals 0, where the region starts, to x equals 3, where the region ends. And that's it. You can solve this one, it's not hard to do. It'd be pi integral from 0 to 3 of x to the 4th dx, which, again, if your instructions say not to do it, you should not do it, but I'm just going to show it to you guys anyway. Right, you're just wasting your time if your instructions say not to do it. You get pi times x to the 5th over 5 from 0 to 3, so you get 3 to the 5th, which is 243 pi over 5 minus 0. So that's our answer. Come on, Racer. So that's an example of the disk method, where the region is right next to or flush with the axis of rotation. Another thing of it is your axis of rotation is one of your boundaries for the region. So right, y equals 0, the x-axis was one of the boundaries. Here it's not, right? Y equals x squared, y equals 9, x equals 0 around the x-axis. None of those are the x-axis. Y equals 0 is the x-axis. So we know we're going to have to use the washer method, not the shell method here. So we're still taking the same sort of region. In fact, so y equals x squared. Okay, well, oh no, okay. So I need to be a little extra careful here, because my description wasn't as accurate as it should have been. Now, y equals x squared looks like that. Y equals 9 looks like that, and x equals 0 is that. But am I talking about this region here? Or am I talking about this region here? Usually we mean the one in the first quadrant, although the person writing this really should have specified. I could have even just said, I could have gotten away with not putting this and then just done that and that. But let's go ahead and be more specific. Let's go ahead and just say it's in the first quadrant. Sorry about that, I'll fix that on the practice. And the practice will say on the first quadrant. So I got this region here, region bounded by y equals x squared, y equals 9, x equals 0. In quadrant 1. So we're going around the x-axis, and here we're going to have to use the washer method. So here our strip, our vertical strip, right, perpendicular to the axis of rotation. When we revolve that around, we're going to get something that looks like and then this part here, it's cut out. Right? So when we revolve that around, right, it's this little shape here getting revolved around. And so we got this washer, and just like the disc, the volume of the washer is the area, pi r squared, times the thickness. The difference here is that we also subtract out this volume. So the volume of the washer is pi times the big radius squared minus pi times the little radius squared times the thickness, which is dx. The big radius is the outer function. That's just y equals 9. The inner radius is the closer function, which is x squared. So the volume of my washer is pi times 9 squared minus x squared dx. In fact, I have the pi. So my total volume would be given by, again, so now it's a little less clear. So before it was easy to see that my limits of integration were from 0 to 3. They're actually still the same. We have to work a little harder to see it. Right? So I see that this point here is where y is equal to 9. So this is y equals x squared. This function is y equal to 9. And we set this equal to each other. I get x squared equal to 9, so I get x equal to 3. So we still are going as far left as 0 and as far right as 3. Find out the pi. And you can leave this as is, or you can simplify this 81 minus x to the 4th. And that's how you would set that up. Alright.